Okay, sir.
Screen కనిపిస్తుందమ్మా?
Yes, కనిపిస్తుంది sir.
Okay, this is your textbook. Okay.
Okay, sir.
In my laptop, the written form is not working. So just now I want to explain thermodynamics topics today. So what is thermodynamics? Anyone? What is thermodynamics? Yes, what is thermodynamics? Don't you know? Yes, what is thermodynamics?
Study of heat, work, temperature and energy, sir.
Yes, in chemical reaction, temperature, we have some several reactions. In reactions which are accompanied by the evolution of heat energy. It may be absorption, it may be evolution, it may be exit temperature, it may be observe the temperature. We can call it as a thermodynamic reactions. Okay, exothermic and endothermic. What exactly? Exothermic or endothermic reactions. We can call it as a some thermodynamic reactions we have. In the reaction we have reactants and products. Reactants and products. Okay. For example, we have A plus B. We can see the screen. Okay, exothermic. What is the exothermic reaction? What is endothermic reactions we have? Is it okay? All of you. So A plus B, these are the reactants. These are the reactants. What are the products? C plus D is a products. Is it okay? So in this reaction we have reactants combination. Combine the reactions, it give the products or not. So some energy is released. It indicate with negative sign or positive sign. We should check it. So evaluate some temperature, some heat energy. So it is exit. If it is exit, we can call it as a exothermic reaction. The heat energy is exit from the reaction. We can call it as a exothermic reaction. Thermic is nothing but temperature or heat. We can call it as that is the exothermic reaction. What is the endothermic reaction? So whenever energy is observed, so we want to produce the product from the reactants. We can call it as a endothermic reaction. Clear? What is exothermic? What is endothermic? Is it okay? So thermodynamics is in chemical reaction, it may be the energy liberated, heat energy liberated or observed or evolution. We can call it as a thermodynamic study of the. What is the thermodynamic study of the? Anyone? What is the thermodynamics?
Study of the heat, energy and temperature, sir.
That's it. energy changes using the temperature in chemical reaction. So with the energy changes in the chemical reaction, energy changes. It is a not converted. It is a energy changes in the reaction using the temperature. Okay, we can call it as a thermodynamic reactions. Is it okay? What is exothermic? What is endothermic? Got it or not? Yes. What is the first example? General type A plus B to C plus D. A plus B to C plus D. So A plus B is a reactant, C plus D is a products. Here we have internal energies of reactants. Internal EA comma EB. What is the E? E for energy. So what are the product? EC and ED. Is it okay? So these are the why we are using symbol of greater than. EA plus EB greater than EC plus ED. So this is the first law of thermodynamics. What is the first law of thermodynamics? Anyone? What is the first law? Anyone know? So first law is nothing but here the energy in process may be transferred from one form to into the other, but neither created nor destroyed. Is it okay or not? So that's why we are using symbol of greater than. That is a conservation law, law of conservation. So energy, it is not created, it may be not destroyed. So it is a one form to another form. That is the first law of thermodynamics. Is it okay or not? ఎనర్జీ అనేది మనం క్రియేట్ చేయలేమమ్మా, వన్ ఫామ్ టు అనదర్ ఫామ్ కి వెళ్ళిపోతుంది. సో బైక్ లో ఫ్యూయల్ వేసామనుకో అది ఏమవుతుంది, స్మోక్ లాగా కన్వర్ట్ అవుతుంది, బట్ డిస్ట్రాయ్ కాదు అక్కడ. ఇస్ ఇట్ ఓకే? సో ఇట్ ఈస్ ఏ డెల్టా యూ ఈజ్ ఈక్వల్ టు క్యూ ప్లస్ డబ్ల్యూ. దట్ ఈస్ ద ఫస్ట్ లా ఆఫ్ థర్మోడైనమిక్స్. ఇది రిటర్న్ ఫామ్ చేయడానికి నాది స్క్రీన్ రావట్లేదు, సో అందుకోసమే ఓవరాల్ గానే చెప్పేస్తున్నాను. నెక్స్ట్ క్లాస్ కి వరకు అరేంజ్ చేస్తాను నేను. ఇస్ ఇట్ ఓకే? టుమారో వి హ్యావ్ అనదర్ క్లాస్. ఓకే, Q is a heat evolved in the reaction. So if it is evolved, we can, what is the symbol? Minus Q. Delta is equal to minus Q. Delta is equal to, if it is observed, we can indicate with plus Q. If delta, if energy is observed, we can indicate with plus Q. Is it okay? This is a minus Q is nothing but it is a heat energy evolved, means it is releasing. That is called exothermic reaction. What is endothermic? If heat energy is observed, we can indicate with plus Q. Okay, copper react with sulfur. Copper react with sulfur. CuS, copper sulfide. What is the plus? 11,600 calories. It is observed or evolved in the reaction. Plus some symbol is nothing but exothermic or endothermic. So this is the
Exothermic.
Exit is nothing but minus charge. Is it okay? Plus is nothing but absorption. Combination reaction. This is the combination reaction. Is it okay? It's a combination reaction. Cu plus S combining. So we want to give the some heat energy. Is it okay?
Yes, sir.
Yes. So this is you can read it once. What is exothermic? What is endothermic reaction? Yes. Same example here we have thermochemical reaction. Thermochemical reaction is nothing but, so it is taking energy. Sometimes it is releasing energy. Difference between the copper sulfide and carbon dioxide. What is the difference here? So you need to combine. Is it okay? So here we have whether it may be solid or liquid. It is a allotropic modification, is a nothing but, so Cu depend on the reactant, it may be liberated, it may be observed the temperature. For example, we have copper is a solid or liquid. It is a solid. What is that? S is nothing but sulfur. It is a rhombic sulfur. Sometimes it is a gaseous state. Depend on the volume, temperature, temperature. We have the depend on the temperature only. Temperature and volume of the given compound. It may be observed. It may be evolve the temperature in the reaction. Here we have, so copper react with sulfur, it converted to the before reaction, it is a before reaction, copper sulfur reaction. So it is a taking the energy or observe evaluate the energy, releasing or observing. In the CUS minus is a nothing but exothermic or endothermic?
Exothermic, sir.
Minus is a nothing but
Exothermic.
yes, exit the temperature. What about carbon dioxide? Carbon dioxide is a
Endothermic.
endothermic. Got it or not? So this is the thermochemical reactions. Thermochemical reactions. What is the first law of thermodynamics?
Energy is not created now, but not destroyed. It may be converted one form to another.
So this is the first law of thermodynamics. We indicate with delta H plus delta already Q plus W. We can call it as a delta U is equal to. Here we can indicate delta is H is equal to delta E plus P delta V. So here P is nothing but pressure. Whenever we are applying the temperature, it may be releasing the temperature, it will be pressure is there. So delta E is a energy. What is delta H? What is delta H? Anyone? Do you know enthalpy, entropy? What is enthalpy and entropy? Yes, anyone? Don't you know anyone? What is enthalpy? What is entropy? Delta H is a enthalpy. Enthalpy is nothing but this is a internal energy. So this is the energy of temperature. It may be released or it may be observed. We can call it as a enthalpy. The change in the chemical reaction. Okay, the heat change involved in the change of phase. It may be physical state of 1 mole of compound. 1 mole is nothing but it may be solid. That depend on the temperature. In solid particles, we have observed the more energy. What about compared to the solid, liquid, gas? So in liquid we have, it is observed compared to the solid, it take a less heat energy. What about gas? Gas is a compared to the solid, liquid, it is a take less energy. So that is the difference between solid, gas, liquid. Is it okay? That is a change between the temperature, phase transformation of heat energy, change in the reaction. We can call it as a enthalpy. Delta H is a enthalpy. Is it okay or not? Yes. So delta H is equal to delta E plus delta P delta P. V is a nothing but depend on the volume. Volume is a depend on the product. It may be it may be take more time. If it is volume is very high, means delta V represents the difference between the volume of products, volume of reactants. Got it or not? If it is only solids and liquids, the change in their volume, result of reaction will be negligible, because the gases are, it is easily give the products. It is taking less temperature. Okay, what we are learning now? Thermochemical reaction. Chemical equations taking temperature. Is it okay?
Yes, sir.
Yes. Delta V, what is the delta V? Here, difference between the products, the volume of reactants. Already I explained about. Delta H is a nearly equal. Is it okay? So coming to the solids. What is a solid? Yes. So this is a one is a solid, one is a liquid. H2SO4 is a sulfuric acid. Metal react with acid, it gives the hydrogen gas. It gives the hydrogen gas or not? Here we have in this reaction. So Zn plus H2, Zn, zinc react with H2SO4, sulfuric acid. So it converted to the ZnSO4 and hydrogen. It is a hydrogen gas is produced. The volume of H2SO4 or zinc dissolved in will negligible. Nothing but here we have which one is a more concentrated H2SO4 solid. Zn is a solid. So volume depend on the liquid and metal. So volume is a nothing but it is a we are taking more volume of H2SO4. Is it okay? So delta V is equal to Vp and Vr. Both are gases or not? Vp is a nothing but products, Vr is a reactant. Is it okay? PV is equal to PV product and NPR RT, PR is equal to nRT. So what is the reactions, reactants and products? The relation between the reactants and products here we have. Is it okay? The relationship between delta U and delta H. Before that, I told about that delta H. What is the delta H? What is the delta U? So delta H is equal to delta U plus delta nRT. Here, the temperature, mass of the substance, and Q is a heat required. So C is a specific heat here. C is a specific heat. We don't have C here. You should remember in this equation. So PV. Is it okay? Cp minus Cv is a R. Here Cp is a molar heat capacity at constant temperature. V is a nothing but what is a V? Heat capacity at constant value. R is a nothing but universal gas constant. N is a number of moles. What is the N? Number of moles we are taking. R is a nothing but universal gas constant, universal gas. Okay, nRT. Okay, R is a universal gas constant, T is a temperature. Is it okay? N is a number of moles. Moles here we have. Okay, number of moles we are taking. N is a nothing but. Yes.
Yes, sir.
Delta G is equal to delta H minus T delta S. So this is the relation between it is a Gibbs energy, we can call it as, I will explain next topic. What is the Gibbs energy? Is it okay? Delta H is equal to delta E plus delta nRT. Delta nRT. Delta H. What is the delta H? What is delta U?
అందుకే 5 ఏళ్ళ నుంచి ఇంటికి కూడా పోలే నీ ప్రాణం తెద్దామని పేరు మార్చుకుని పాలేరులో పనిచేశా 4 రోజులు కట్టేసింది మా అన్న వీరస్వామి కాదు నీ మీదకి తప్పించుకున్నాం.
Yes.
సార్ ఎవరో సినిమా పెట్టినారు
ఏంటండి?
తీసుకోరా. ఏంటి చూస్తున్నావు? పసుపు ఊహించినప్పుడు వచ్చేది సాగు, ముహూర్తం పెట్టి చేసుకునేది పెళ్లి.
నీకు వెయ్యేనా? ఏంది
సార్
నేను అడుగుతాడా? ఒకటి ఎక్కువ అడిగింది.
ఎవరమ్మా ఆఫ్ చేయండి.
ఆ ముసలంతో సహా మీరు చెప్పగలే.
మీరేంటి చేయట్లేదు?
సార్ మీ వాయిస్ ఏం వినిపించట్లేదు సార్.
అదే ఎవరు ఆన్ చేశారమ్మా?
ఎవరో నేహ అంటే సార్.
నేహా సఫీన్.
ఎస్ సార్.
సార్ మరి ఎట్లా అది ఆన్ చేయడం ఆఫ్ చేయడం? ఎస్ ఎస్ ఫైన్ ఫైన్. ఈజ్ ఇట్ ఓకే? ఇది అర్థమైందమ్మా? డెల్టా హెచ్ ఇస్ ఈక్వల్ డెల్టా ఈ ప్లస్ డెల్టా ఎన్ఆర్టీ ఎలా వచ్చింది అనేది. థర్మోకెమికల్ రియాక్షన్ వీ హ్యావ్ సమ్ చేంజెస్. సో ఇక్కడ ఎగ్జాంపుల్స్ ఒకసారి అబ్జర్వ్ చేస్తే ఇక్కడ ఏముంది? సో ఇక్కడ మీథేన్ అనేది ఫామ్ కావాలి మనకు. CH4 is nothing but methane. So here carbon react with hydrogens, it gives the CH4. Okay, ఇక్కడ heat reaction, we are combining the carbon and hydrogen, so this is a combination reaction. Okay, so thermochemical reaction we can call it. We are learning about thermochemical reactions. Delta N is equal to 1 minus 2 is equal to minus 1. Minus is a nothing but it is a taking energy or not. It is a exothermic or endothermic? Minus is indicating
Exothermic.
yes, it is taking and releasing energy, same thing. So here what about this one? This is it is not combination reaction, it is a combustion reaction. In combustion also taking some heat energy as well as releasing the energy also. Is it okay? So now we can calculate the reaction constant pressure. Delta H is equal to E plus delta nRT. The given values we can substitute it. We get the value. Is it okay?
Yes sir.
S law of constant heat summation. So we have some reactions, nothing but so the reaction A plus A2, A is a some reactant, B is the product. So it converted to one step reactions. It may be one step is nothing but the heat energy released in 4, it may be 4 calories in the one step reaction. So S law is a what exactly it defined? It may be, look at the steps here. So what is the first step here? We have A to B. A to B. In A to B some Q energy. The energy is liberated. A to B. So for example 4. The temperature is 4. So it will take 2-step reaction. We can divide into 2 steps. A to C, what is a Q1? Q1 is equal to 2. The temperature is 2. It converted to the C to B. It is a second step. That is a Q2. Okay, the volume is equal to Q1 plus Q2 is equal to Q only. 2 plus 2, 4. Before that also we have how much energy we got? 4. The temperature is a some 4. Example, the temperature is a 4. It converted to delta E and delta H heats of reaction measured constant volume at constant pressure. In the reaction, what is the reactants? A to B is A is a reactant, B is a product. Okay, it may be in S law we have constant heat summation. Summation is nothing but if maybe add between the A to B or A to C, C to B. So both are same. So that is it okay? So S law is a constant heat summation states the total heat change in reaction is the same whether the chemical reaction takes place in a single step or in several steps. The total summation are same. Summation is nothing but suppose A to B, the evaluated temperature is a 4. So that is equal to A to C is a first step. It takes the temperature is a 2. The C to B, the evaluated temperature is 2. The summation between the Q1 and Q2, it gives the temperature is a 4. So that is the S law of constant heat summation. Once again, S law of constant heat summation states that the total heat changes in a reaction is the same whether the chemical reaction takes place in single step or several steps. ఒక స్టెప్ మనకు A to B ఒక రియాక్షన్ అయినప్పుడు ఎంత ఎనర్జీ రిలీజ్ అవుతుందో A to C కి అదే ఎనర్జీ రిలీజ్ అవుతుంది అంటే మీన్స్ హాఫ్ ఆఫ్ ద రియాక్షన్ అవుతున్నా కూడా సెవరల్ స్టెప్స్ తీసుకున్నా not only 2 steps, it may be more steps, more than 1, 2, 3, 4. The summation of it is a equal. Same reaction, it is taking some steps, several steps, not only 1, 2. Q1 దగ్గర 2 వచ్చింది అనుకోండి వాల్యూమ్, Q2 దగ్గర 2 వస్తే అవి రెండింటిని కలిపినప్పుడు 4 వస్తుంది మనకు టెంపరేచర్. ఓకేనా, హీట్ సమ్మేషన్ అంటున్నాం కదా, అవి రెండింటిని యాడ్ చేస్తే మనకు మళ్ళీ 4 రావాలి అనేది కొన్ని రియాక్షన్స్ కి మాత్రమే ఇది అప్లికేబుల్ అవుతుందని చెప్పిండు. ఓకేనా, డైరెక్ట్ 1 స్టెప్ లో కూడా ఎనర్జీ అంతే రిలీజ్ అవుతుంది. సేమ్ క్యాలరీస్ ఆఫ్ హీట్ లిబరేటెడ్ A to B that indicate with Q through an intermediate, it may be C. Okay, 2 step Q1 Q2 calories of heat are liberated, both are same. We can say the total heat change in reaction is the same whether the chemical reaction takes place in a single step or several steps, both are same. Is it okay? That is the S law of constant heat summation. Is it okay? Yes. ఇది అర్థమైందమ్మా? S law of constant heat summation ఇందులో ఏం లేదు.
Yes, sir.
ఒక్క స్టెప్ లో అయినా అంతే క్యాలరీస్ ఎనర్జీ రిలీజ్ అవుతుంది. More than 1, it may be several steps, it may be take 1 or 2 or 3. So the heat energy is the same. Okay, it is releasing A plus B Q1, A plus B Q1, B plus C. Suppose A to D, we have some reactions A to D. It is giving A is a reactant, D is a product. Between the A plus B, B plus C, C plus D, it is taking more steps Q1, Q2, Q3. Combine చేస్తే సేమ్ వస్తుంది అనేది చెప్తున్నాడు. S law of constant heat summation. Is it okay? ఒకసారి రీడ్ చేయండి. టెక్స్ట్ బుక్స్ ఉన్నాయా మీకు అందరికి?
No, sir. No, sir.
ఒకసారి మీరు వాట్సాప్ మెసేజ్ చేయండి, ఇది పంపిస్తాను మీకు. ఒకసారి రెఫర్ చేసుకోవచ్చు మీరు. అన్ని లెసన్స్ ఉన్నాయి, మీకు అన్ని యూనిట్స్ ఉన్నాయి ఇందులో. ఇది PDF పంపించేస్తాను మీకు. మీకు ఆఫ్టర్ క్లాస్ ఒకసారి సెండ్ మీ టెక్స్ట్ బుక్ సార్ అని పెట్టండి, నేను పంపించేస్తాను. యూస్ఫుల్ ఉంటుంది ఇది మీకు. ఇది కూడా లేకుంటే ఎట్లా చదువుతారమ్మా? సో ఇక్కడ ఏంటిదమ్మా, ఇండైరెక్ట్ క్యాలిక్యులేషన్ ఆఫ్ హీట్స్ ఆఫ్ రియాక్షన్స్. ఓకేనా? సో ఎస్లా అర్థమైంది కదా. ఒక స్టెప్లో అయినా 2 స్టెప్లు అయినా 3 స్టెప్స్ అయినా ఎనర్జీ అనేది చేంజ్ కాదు. కన్జర్వేషన్ లా ఆఫ్ కన్జర్వేషన్ అనేది మనం చిన్నప్పుడు చదువుకున్నాం, లా ఆఫ్ కన్జర్వేషన్. సో సేమ్ ఎస్లా కూడా అదే చెప్పాడు. ఇక్కడ ఏం లేదు, ఇండైరెక్ట్ గా అది ఉంది, డైరెక్ట్ గా ఇది చెప్పారు. వాట్ ఇట్ ఆర్ నాట్? ఎస్. సో నెక్స్ట్ వన్ ఏంటిదమ్మా? ఇండైరెక్ట్ క్యాలిక్యులేషన్ ఆఫ్ హీట్స్ ఆఫ్ రియాక్షన్స్. సో we can combine thermochemical equations. Enthalpy, entropy. We should know the definition. Enthalpy. Enthalpy. What is enthalpy? What is entropy? So enthalpy, entropy. What is enthalpy? What is entropy? ఇంతకుముందు ఏం చెప్పాను మీకు ఎంథాల్పీ అన్నానా ఎంట్రోపీ అని డెఫినేషన్ చెప్పాను కదమ్మా. Yes, anyone? What is enthalpy? What is entropy?
Measure of total heat present in the thermodynamic system, sir.
Yes. Phase transformation, enthalpy. What is entropy? ఈ రెండు డెఫినేషన్ తెలియాలి థర్మోడైనమిక్స్ చదివేటప్పుడు మనకి. Enthalpy and entropy. What is entropy? So it may be disorder. Entropy is nothing but, so we should know how to calculate the indirect calculation we have here. So entropy is nothing but, so what exactly indirect calculation of heats of reaction. Why we are taking indirect calculation? So entropy we should know, entropy and enthalpy. So enthalpy is a chemical change. It is a converted to reactant to product. So it may be heat, energy absorbed or evolved. We can call it as a entropy. So what is a enthalpy? Enthalpy is nothing but, it is a disorder. Disorder is nothing but ice converted to the water, water converted to the water vapor. So the volume is changed or not, the volume of the reactant, it may be changing or not. So ice is a solid, water is a liquid, vapor is a gaseous state. So here disorder of molecules or randomness of the system is called entropy. What is entropy? Ice converted to the water, water converted to the vapor, water vapor. So here disorder of the molecules, arrangement of the ions inside the atom, inside the compound. So randomness of the system, is it randomly changing or not? Is it okay? This is the extensive property. Entropy is a extensive property. What is extensive property? So here we have extensive is nothing but, so we are using some temperature or pressure, that is an extensive property. Ice is a solid, water is a liquid, vapor is a gaseous state. So the quantity, how can we measure? We are using some thermo, means some temperature, thermodynamical quantity which measures or disorder of molecules or randomness of the system is called entropy. Fine. What is entropy? Got it or not?
Yes, sir.
What is the enthalpy? Enthalpy is nothing but it is the changes of energy that is related to energy. This is related to phase or state of the compound. It may be physical state is nothing but it may be solid, liquid, gas. That is the entropy. What is the enthalpy? Energy change in the reaction, or energy liberated, or energy observed in chemical reaction. We can call it as a enthalpy. What is entropy? Molecular disorder, disorders of molecules. Okay. The entropy denoted by S. What is the symbol of S? S is a entropy. Enthalpy is a H, delta H. It may be energy changes. Is it okay? So it is a reversible process or not? Ice, water, vapor. It is a reversible or not? Okay. In entropy, it is a reversible process. That is the entropy. What is enthalpy? Enthalpy is a energy. It is related to energy. It is a disorder of molecule is called entropy. Got it? Fine. So the difference between enthalpy and entropy. Yes. So here in thermodynamical equation, whose have enthalpy change. Enthalpy change we cannot determine experimentally. So there is a large number of reactions. Heat change cannot be measured either because the reaction does not take place to completion or more one product result from the reaction. To such reaction, S law can applied obtaining their H values. Okay, so we can take the not single step, we can take the more than one step. So that is the we can apply the Hess law. So we can combine it. In first step we have some energy, it may be 2. Second step 2. Third step is a 2. So we can summation of the energy or not. So it converted to the we can apply the S law. This is the indirect calculation. We are using S law. In enthalpy we cannot find, we cannot determine. Enthalpy is nothing but some energy we cannot find in the reactions. We can use the S law. We can take one or more steps. Okay, na? So this is the heat calculation, indirect calculation in chemical reactions. Okay. Carbon combined with oxygen, CO2, it gives the 94,050 calories. So what about that second step? 67,900 calories. What is the difference between first one and second one? What we are taking carbon react with oxygen. First half mole, we are taking half mole. We can calculate both values. It gives the same energy. Is it okay or not? So we can may write delta H is equal to 26,150 calories. Okay, na? The heat change of the reaction depend on the reactants. So if we combine the energy, means it is a minus sign is indicating liberated or observed. Minus is nothing but liberated energy. It is exothermic reaction. Okay. Plus is nothing but observed. It is an endothermic reaction. Is it okay?
Yes, sir.
Yes. Check it once. Heat of formation. Heat of formation. The amount of heat is observed or evolved in the formation 1 mole of compound from its element is called heat of formation of the compound. So here we are applying energy or it is taking energy or releasing energy in the reaction. First of all, carbon react with oxygen. It converted to the carbon dioxide. So both reactant are same. In the two reactions we have combination reaction. This is the amount of heat observed or evolved in the formation of 1 mole of compound. Its element is called heat of formation. So in first step we are observing, second one is a releasing. So any difference between the two reaction? The heat changes in the reactions are formation of the compound formed in the respective reaction. So here before that, what we are doing, the combining and combustion reaction. That is the first one is a combustion reaction. Second one is a formation of compound. Second one is a combination reaction. First one is a combustion reaction. Second one is a combination reaction. The reactions are the heat formation, the compound formed in the reaction respect to, it is a related to, that is the first one is a combustion. Carbon combustion, presence of oxygen. It converted to the carbon dioxide gas. So that is the observing heat energy. Second one is a endothermic, liberated heat energy. Carbon combined with hydrogen, it converted to the methane gas, CH4. Okay, now that is a thermochemical reactions, equations combined with the hydrogen and oxygen, it converted to the water. So this is the, both are heat absorption reactions. Hydrogen react with chlorine, it gives the hydrochloric acid or hydrogen chloride. Is it okay? What is heat reaction? Heat of reaction. Just write the definition. Write the definition and one example. One or two. That is a carbon react with oxygen, it gives the carbon dioxide. Okay. And carbon react with hydrogen, it gives the methane gas. You should remember that how much calories, energy evolved in that reaction or observed in the reaction, we should write enough. So this is a combined compound, name of the compound, how much heat energy is released or observed. Ammonia, nitrogen react with hydrogen, it give the, this is a minus 11,040, means 11,040. Absorption, how much absorbing the energy and release the energy. Okay, just take it once. Heat of combustion, just now explained, combustion is nothing but it is taking some energy. Combustion is we are applying only energy, applying in the combustion reaction. Okay, combustion, combination, combustion of a compound is amount of heat energy liberated. So liberated is nothing but it is taking energy and liberate the, when 1 mole of the compound is completely burned in oxygen, such values are important for fuels or foods because heat of combustion values. Okay, now digestion, our digestion process also combustion reaction. Combustion, it takes place. We are taking oxygen for combustion, for digestion. So some energy released or not after digestion. That's why we are doing some works. Combustion reaction. When 1 mole of sucrose is nothing but what is a glucose C6H12O6. Sucrose is a combination of 2 glucose molecules, C12H22O11. So combustion, presence of oxygen, it converted to the carbon dioxide and water. Is it okay? Minus 1348.9. It is the energy completely burned in oxygen. So the 13,048 calories energy is liberated. Okay, now heat of combustion. In the heading we have combustion of the some chemicals, presence of oxygen. The energy is liberated or observed the energy in the reaction. Is it okay? So same thing, alcohol, presence of oxygen. So here also, which one carbohydrates are organic compounds where combustion, presence of oxygen, it give the carbon dioxide and water molecules. Okay, once again, organic compounds, what we are doing, presence of oxygen, presence of the reaction is a combustion, it gives carbon dioxide and water. Okay, that is aromatic compound, benzene, C6H6. Okay, presence of oxygen, 7.5 oxygens we are taking. It converted to the carbon dioxide and water. Okay, it is taking energy. Okay, it is taking heat energy. So that is the heat of combustion. What is the, you can easily balance it. You can easily balance the reaction. Is it okay? What is the heat of combustion? Before that, we know that what is the chemical reactions, exothermic and endothermic. Heat of combustion, indirect calculation process, This is the indirect calculation process. After that, Tesla is very easy. It taking several steps or one step, the energy is the same. Heat of formation. So Tesla, okay. What is exothermic reaction? What is endothermic reaction? Okay, indirect calculation of heat reactions, heat of formation, heat of combustion. Okay, heat changes in solution. Next one is a, yes, anyone, any doubt? So I don't have that notepad. So next one. Thermochemical equations. In thermochemical equations, we have released heat energy or observed heat energy. S law, constant heat summation. So the energy is a constant. It will take one step or two steps or three steps or four steps. It may be the heat is a constant. When we combine after the reactions, we take the more than one step or two steps. Heat of formation in the reaction. It may be observed it may be released with that. It may be formation in the chemical reaction. So they gave some values for those compounds. So next one is a heat of combustion is over. It may be we are taking organic compounds. It may be glucose or sucrose. We are taking. Okay. Yes. What is this? So this is a determination of heat of combustion. So the energy is a releasing. The energy is observing. It may be. So it may be 780.98. The heat energy we are taking. How it will be? We are using calorimeter. So how many calories? CALS is nothing but calories. So this is a symbol of calories. So we are taking calorimeter. That is a bomb calorimeter. So what is the arrangement here? You can read it once. Just what is what I am explaining here. So we are using some thermometers here. Okay, which compound we are taking, we can keep the inside here. So those are the reactants we are taking. So it converted to the thermometers we have. So weight of the sample we should know. One minute, yes. Okay. So this is the Bombo calorimeter. Here we have in Bombo calorimeter as a in the shown in the diagram we can see what is the operators here we have. So metallic supports connected to the lid. Is it okay? మీరు ఒకసారి చదివితే అర్థమైపోతుందమ్మా ఇది ఎక్కడ ఎలా ఉంది ఏంటిది ఏమేమి అరేంజ్మెంట్స్ ఉన్నాయి దాన్ని ఎలా తీసుకుంటారు టెంపరేచర్ అనేది ఎట్లా అవుతుంది T2 - T1 ఒక్కసారి రీడ్ చేయండి అది ఓకేనా అర్థమైపోతుంది టెంపరేచర్ అనేది ఎట్లా తీసుకుంటున్నాం అనేది బాంబో క్యాలరీమీటర్ yes after that we have ఒక్కసారి చూడండి దాంతో రియాక్షన్ ఎట్లా కంబైన్ అయ్యాయి ఎట్లా వచ్చినాయి అనేది హీట్ చేంజెస్ ఇన్ సొల్యూషన్ what is the heat changes in solution so here we have heat changes is nothing but solid liquid react with solid and liquid it converted to the this evolved energy or observed energy we know that so in solution we take both solutions so heat is a constant it may be absorbed more energy or released more energy depend on the liquids what is the solution solute plus solvent equal to solution okay now what is the solution solution is nothing but solvent solute equal to solution okay so heat changes in solution coming to the here it may be the solution when compound for example sodium hydroxide and sulfuric acid what is the sodium hydroxide is it base or acid Yes, anyone? Sodium hydroxide is base or acid? Yes. Sodium hydroxide is base or acid? Yes.
Base.
Yes. What is H2SO4?
Acid.
Acid. H2SO4 combined with base acid. It converted to the which reaction? This is a neutralization reaction. Got it or not? Neutralization reaction combined with acid and base. So this is the heat changes in solution. We are taking combination with acid and base. It gives the neutral or not? Is it okay not? Heat of neutralization of acids and bases. Next one. So this is a combination of acid base. The some heat energy is released. Okay, combine the reactants. Here we have combination of reactants. Some heat energy is liberated. So where as a solution resulting from dissolving and sodium hydroxide and H2SO4. So after some time it becomes a cool, and the solution, the heat energy has absorbed inside the solutions. That is the heat changes in solution. More than 1 minute. Look at here. Heat of neutralization. Neutralization equal to heat changes in solutions. Both are same concept. You can see the example here. KOH react with HCl. KOH is a base, HCl is a acid. Okay, so acid is a neutralized by base. When a dilute solution of an acid is added to the dilute solution of base. So this is a KOH react with HCl. It converted to the KCl and H2O. So dilute solutions combined heat energy is liberated first thing. So after that the products of this reaction salt and water. So రెండు కంబైన్ అయిపోయాయి అనుకోండి, యాసిడ్ బేస్ కొంచెం హీట్ ఎనర్జీ అనేది రిలీజ్ అవుతుంది, కానీ ఇది లిబరేట్ కాదు, బయటకి లిబరేట్ కాదు. ఏమవుతుంది తర్వాత మళ్ళీ న్యూట్రలైజ్ అయినప్పుడు ఆ హీట్ ఎనర్జీని మళ్ళీ అబ్జర్వ్ చేసుకుంటుంది. ఓకేనా? అందుకే స్మాల్ అమౌంట్ హీట్ అనేది -13.695. సో ఇక్కడ ఏమవుతుందంటే KOH అనేది న్యూట్రలైజేషన్ అవుతుంది HCl తోటి యాసిడ్ బేస్ కలిసినప్పుడు. అందుకే న్యూట్రలైజేషన్ హీట్ ఎనర్జీ ఆఫ్ న్యూట్రలైజేషన్ యాసిడ్ బేస్ లోనే ఉంటుంది. మోర్ ఎక్స్పెక్టేషన్ ఉండదు, హై హీట్ ఎనర్జీ అనేది రిలీజ్ కాదు ఇక్కడ. హీట్ ఎనర్జీ అనేది రిలీజ్ కాదు. గట్ ఇట్ ఆర్ నాట్? బయటకి ఎక్కువ రిలీజ్ కాదు, కొంచెం టెంపరేచర్ అనేది మాలిక్యూల్ మధ్యలో ఉంటుంది. తర్వాత ఏమవుతుందంటే మళ్ళీ అబ్జర్ప్షన్ అయిపోయి కూల్ అయిపోతుంది. అంటే ఇక్కడ హీట్ అనేది లిబరేట్ కాలేదు, అబ్జర్వ్ కాలేదని చెప్పొచ్చు. ఓకేనా? అయనైజేషన్ అవుతుంది. ఇక్కడ స్ట్రాంగ్ యాసిడ్ స్ట్రాంగ్ బేసెస్ తీసుకున్నా కూడా అయనైజేషన్ అయిపోయి డైల్యూట్ సొల్యూషన్స్. ఎందుకంటే న్యూట్రలైజేషన్ అనేది అక్కడే చెప్తున్నాం మనం, న్యూట్రలైజేషన్ అవుతుంది. ఇక్కడ వాటర్ మాలిక్యూల్ వస్తుంది, సాల్ట్ వస్తుంది. 50% ఆఫ్ యాసిడ్ 50% ఆఫ్ బేస్ అనేది కంబైండ్ అయిపోతే మనకి ఏమవుతుంది, సాల్ట్ అండ్ వాటర్ ఫామ్ అవుతుంది. న్యూట్రలైజేషన్ ఆఫ్ హీట్ అనేది ఇక్కడ వస్తుంది. ఎందుకంటే అక్కడ న్యూట్రలైజేషన్ రియాక్షనే కాబట్టి హీట్ ఎనర్జీ కూడా అలానే అవుతుంది. తీసుకోదు, అబ్జర్వ్ చేసుకోదు, రిలీజ్ కాదని చెప్పొచ్చు కొంచెం బయటకు వస్తే. ఎస్, గాట్ ఇట్ ఆర్ నాట్? న్యూట్రలైజేషన్, హీట్ ఆఫ్ న్యూట్రలైజేషన్, ఇవన్నీ సేమ్ రియాక్షన్స్, సేమ్ ఎగ్జాంపుల్స్. Sodium hydroxide, this is a CH3COOH is a carboxylic acid or ethanoic acid, we can call it as a both example. ఇక్కడ salt CH3COONA is a salt of acetic acid or sodium ethanoate, we can call it as a, this is a water. ఓకేనా? కొంచెం లార్జ్ అమౌంట్ ఆఫ్ హీట్ అనేది వస్తుంది ఇక్కడ. ఎందుకంటే ఆర్గానిక్ కాంపౌండ్, దిస్ is the organic compound. Okay, organic acid, that is a, before that we have it converted to the ionic compound or not? Sodium hydroxide react with HCl. What is the sodium hydroxide? Na plus OH minus. Okay, this is HCl is nothing but H plus Cl minus. It converted to the NaCl and water. ఒక్కసారి రీడ్ చేయండి, మీకు అర్థమవుతుంది. అది ఒకసారి ఈ టెక్స్ట్ బుక్ మీకు పంపిస్తాను. మెసేజ్ పెట్టండి, నాకు మెసేజ్ పెట్టేస్తే నా నెంబర్ వచ్చేసి 9866 ఎస్ 43429 9866 43429. అది మెసేజ్ పెట్టండి అమ్మా. మెసేజ్ పెట్టేసి ఇది మీకు PDF పంపించేస్తాను.
ఓకే సార్, థ్యాంక్ యూ సార్.
9866 43429 సెండ్ మీ PDF 5th సెమిస్టర్ అని పెట్టండి. మళ్ళీ ఒకసారి మీరు రీడ్ చేయండి, కొంచెం ఈజీగా అర్థమవుతాయి అమ్మా.
ఓకే
మీ సైడ్ నుంచి కూడా ఉండాలి.
సార్ బుక్స్ ఎప్పుడు ఇస్తారు?
ఇదే బుక్, ఇది మీకు ఇప్పుడు వరకు ఎక్స్ప్లెయిన్ చేసింది ఇదే బుక్. ఇది సెండ్ చేస్తాను మీకు, PDF సెండ్ చేస్తాను ఇప్పుడు నేను. ఓకేనమ్మా?
ఓకే.
ఈ నెంబర్కి మెసేజ్ పెట్టండి, ఇప్పుడు నేను చెప్పాను కదా 9866. ఇది మీకు ఫార్వర్డ్ చేస్తాను.
ఓకే సార్.
సెండ్ మీ 5th సెమిస్టర్ టెక్స్ట్ బుక్ అని పెట్టండి. ఇది సాఫ్ట్ కాపీ ఉంటుంది మన దగ్గర. ఓకేనా? 9866 43429. ఓకేనా? ఇస్ ఇట్ ఓకే? ఫైన్. మీరు ఒక్కసారి చదవండి అమ్మా. ఆపేస్తున్నాను క్లాస్ ఇంకా.